Let's talk about how we can estimate side lengths or angle measures in two comparable triangles. For example, triangle ABC and triangle DEF have some things in common. Namely, they have one pair of congruent sides called AC and DF, and another pair of congruent sides called AB and DE. However, these two triangles are not congruent to each other because their included angle between those congruent sides is not congruent. 55 is not equal to 36. Remember from a previous lesson that if those two angles were the same, like if they were both 55, then we could use side angle side to prove that the two triangles are congruent to each other. Since those two angle measurements are not congruent, we can conclude that the triangles themselves are not congruent. But that doesn't mean that we can't get any information from this diagram. Instead, we can use something called the Hinge Theorem to make an estimation about the relationship between side BC and side EF, the third sides, the ones that we didn't know. Those sides are across from the two angle measurements that we were given. And since 55 is a larger angle measure than 36, the Hinge Theorem allows us to conclude that BC must be longer than EF. We can also use the converse of the Hinge Theorem to do something similar, but instead of knowing one of the angle measures and then two congruent sides, we know a side length and then two congruent sides. So we do know that these two triangles are not congruent to each other because they only have two pairs of congruent sides and their third sides are not congruent. If these third sides were congruent, then we could use side, side, side to prove that the triangles are congruent. So even though we don't know that the triangles are congruent to each other, we can make some estimations about angle A and angle D. Since this side, BC, is longer than this side, EF, we can conclude that angle A, which is the angle across from that given side length, it must be larger than angle D, because the side opposite from it was larger than the other one. Let's look at some examples. All I'm asking you to do is fill in this blank with either a less than, a greater than, or an equal to. Looking at these two triangles, they're quite comparable. They have two pairs of sides that are congruent. However, their included angles are not congruent, so I know I'm not going to put an equal sign here because these two triangles are not congruent to each other. Instead, I need to look at which angle is smaller or larger to make my assessment of is each side larger or smaller than the other. KL is across from this 83-degree angle, and NO is across from this 88-degree angle. 83 is smaller than 88, so KL is smaller than NO. Our next example only has one pair of sides labeled as congruent, so you might think that the Hinge Theorem doesn't apply. But notice that these two triangles share a side. They both have WY as one of their three side lengths. And we can conclude that WY is congruent to WY using the reflexive property of congruence. So we do indeed have two pairs of congruent sides. However, the included angle between those two congruent sides is not congruent. One of them is 54, the other one is 45. So since 54 is the larger of the two angles, and XY is the side that's across from that larger angle, we can conclude that XY is greater than WZ. We can even use this theorem to make estimations about what that side length might be. So for example, here we have two comparable triangles. They have two pairs of congruent sides. And their third sides are, well, one is given, but the other one's not. One of them is 33, the other one is unknown. The other information that I've been provided is that angle C is 26 degrees, whereas angle F is only 25. So since angle C is larger than angle F, we know that side AB must be longer than side ED. So out of these three options, the only one that would make sense is 34 yards, because 34 is bigger than 33, and 26 is bigger than 25. Let's try the converse of the Hinge Theorem now. We're told that we have two congruent sides on each triangle, and we're told that we have another pair of sides, one of which is 18, the other is 20. Based on this information, we can conclude that angle E, which is the angle that's across from the smaller of the two side lengths, angle E must be less than angle H, because FG was smaller than IJ. We'll have to use the reflexive property again to solve this next problem, because we've only been provided one pair of congruent sides, but we do know that QS is congruent to QS by the reflexive property, so we do indeed have two pairs of congruent sides. And the question is angle PSQ, that's this one down here, is it less than, greater than, or equal to angle RSQ, so this angle right here? What's the relationship between these two angles? Well, the side across from angle PSQ is 72, whereas the side across from RSQ is only 68. That leads me to believe that angle PSQ must be a larger angle than angle RSQ because 72 was bigger than 68. And finally, we can do some estimating for our angle measures. We have two pairs of corresponding sides that are congruent. I see that we have the third pair of sides are not congruent. 76 is actually greater than 75, which means that the measure for angle P must be greater than the angle for angle T. So out of our three options up here, the only one that would make sense is 49 degrees, because since 76 is bigger than 75, 50 must be bigger than angle T. And that's all you need to know about the Hinge theorem, or using inequalities in two triangles to estimate side lengths and angle measures. In our next lesson, we'll be discussing points of concurrency, including orthocenters, circumcenters, incenters, and centroids.